Hello again, this is Jeff Scott. I've been talking to you about Microsoft STL threat modeling, and I found this additional presentation. This was a PowerPoint presentation that was given by Michael Howard, who is the author or co-author of many of the Microsoft STL texts, so I thought I would go over it. I don't know if there'll be a lot of new material in here or not. But he was involved in both the secure development lifecycle books, the writing secure code books, and some of the other books as well. So what he talks about in here, as you can see, the goals of threat modeling, the approach rather that he takes to threat modeling. I don't remember if the exercise is actually in here or not, but if it is, of course, we'll go over it, and some additional learning resources. So, as far as the basics, the who, what, when, where, why, and how type of thing. Alright. It's interesting because I've seen this kind of slide in other things about building the threat model. The developer owns the DFD, the tester owns the threats, the process manager owns the overall process. And the problem with this is, when you look at all those, they all may claim ownership, but the bottom line is whoever writes the code is responsible, in unison with the other people, is responsible for making sure that threats have been identified and mitigated. So the customers for threat models are everyone, internally and externally, who gets involved with the product. Alright, of course the internal people, what do they say, your team there, because these are the people, as mentioned, that are going to have to find or identify, resolve, mitigate the threats. Other product teams, customers who want to know about the threats, especially if they can't be fixed. People like pen testers, because when they hear about these threats and the fact that they have supposedly been mitigated, that'll be some of the tests that they want. And people who are your security advisors, your security gurus, whatever you want to call them. So the idea is, again, that you want to do this using a documented working way of doing it. You want to go through this in a streamlined yet sufficient manner. So notice, as they say, you want to threat model and document the product as a whole, all security relevant features, and any identified attack surfaces. You want some kind of an assurance that this has been done right and it's been done well. Hopefully by now we're to the point where we don't have to ask anymore why to threat model. Again, Microsoft has decreed that software will be secure by design. And as it says, we can improve designs the same way we've improved code. When you think about how code has improved over the years, how compilers have gotten better, how things have been able to be optimized, etc. Alright? We want to do the same kind of thing with security. And also, as mentioned, because attackers think differently. Again, ideally what you're doing when you're starting to threat model is you're thinking like an attacker. But in some ways, at least, to me, thinking like an attacker is kind of like thinking like a child. Because, especially a young child, because you look at a young child, a very impressionable young child, and sometimes you might yell at them, you might say things to them, and you look at them and you really don't have any idea in the world what they're actually thinking. And in much the same way, in the end, no matter how well you threat model, no matter what threats you come up with, no matter what type of mentality you think the attacker may have, you really and truly don't know. You've seen this kind of thing before. Alright, this is Microsoft's vision, that you want to diagram. So you start with a contextual DFD. You want to go in and identify your threats. You want to write more detailed DFDs. Figure out the exact threats, the attack surface. You want to figure out which threats are possible to be mitigated and are worth being mitigated, and mitigate those threats. Then you want to validate what you've done. We've talked about STRIDE and where this fits in it. Remember, STRIDE is an acronym: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. So when you're doing this, you're going to come in, you're going to draw data flow diagrams, you're going to come in and you're going to write use cases, you're going to write detailed things about what can possibly happen and how it can happen. It says there you want a structured way to think about what are you telling customers about the product security. So when you get asked, and you will be, again, the more expensive the product, typically the more you'll be asked. You may be asked to prove your product is secure. And in some ways, I was thinking about that. It's kind of like proving that your automobile is secure. Can you do that? And the answer is yes. However, no matter how secure you think you build your automobile, if you're in an accident and you get hit hard enough, it's still possible that you won't be, the automobile won't make it through the accident, no matter how well, no matter how secure it's been built. All right, so as you go through here, as it says, you go to a whiteboard, and we've talked about this before, that there are basically two ways that you can threat model. One is to bring a bunch of basically security experts together, sit them down in a room and have them brainstorm for one or more sessions. Although this can lead to some really good materials, some really good threats being identified, etc., it also can be very painstaking. It can be very expensive. It can lead to a lot of disagreement. The rules of brainstorming say that you come up with ideas, you shout them out or say them when it's your turn, whatever. But the idea with brainstorming is there is no wild idea. And there is no idea that anyone can turn around and say, no, that doesn't make any sense, because you're not really allowed to comment on what people come up with. Well, that's the way it's supposed to work, but I've been in brainstorming sessions, and it's not the way it does work. You do get people that come into these sessions that have their own agendas, that think that things should work in a certain way, etc. All right, and for those people, they can make brainstorming very tough to do. So the other way is to use your data flow diagrams. You start with a contextual diagram, and with the contextual diagram, you want to include your processes, your data stores, your data flows, your trust boundaries, all right, your external data sources, etc. Very important point right there. The second bullet, main bullet, says you must update these diagrams as the product changes, and that's tough to do. You've gone through and you've invested all this time and capital in coming up with these threat models and these diagrams. But now there's major project changes. Well, you might be a little bit behind already, and now you're supposed to go back after that and update the diagram? The answer is yes, because the threat model tool is also a source of documentation. You keep the original threat models, the original DFDs, etc., but then you update them and you have those in there also. This will allow you, as it says there, to enumerate assumptions and dependencies. You need that kind of stuff from the get-go. Remember, these are our major symbols in a data flow diagram. You've got the square, which is an external entity. Oftentimes, they're either external people or external systems. You've got your circle. It can also be a rounded rectangle with a line through it, but it's normally shown as a circle, which are your processes. And when you look through here, that's basically your code. Sometimes in an earlier or a contextual or a high-level document, you might have a double circle, a circle within a circle. And what that means is that you've got a process that needs to be broken down into sub-processes somewhere along the way. You've got a data flow, which typically shows something flowing into a system, a process, or whatever, and things flowing out. Sometimes your inputs and your outputs. You've got a data store, and it can be several things as shown here, but most often data stores are equated with databases and files. And finally, you've got the trust boundary. This isn't a typical DFD symbol. The DFD symbols are the top four. The trust boundary down near the bottom is one that's been identified by Microsoft itself. As it says, you must add these trust boundaries when you've got an intersection of data flows. What you're trying to do is you're trying to identify here those points in the system where the attacker might most likely try to attack. As you can see, there are several examples of boundaries. There's machine boundaries, privilege boundaries, integrity boundaries, people boundaries. Threads in a native process, as it says, are often inside of a trust boundary because they share different things. And when you go from one permission to another, it's another place you might have a trust boundary. All right. So when you go from somebody who has administrative position to someone who has non-administrative permissions, I should say. Processes talking across the network always have an associated trust boundary. All right. So again, you write these DFDs, you start with a high-level contextual diagram, and you keep writing more higher-level ones. So how do you know when you're done? You're done when you think that basically, for lack of better words, you can't break it down anymore. You iterate over these. Again, one of the things you're trying to do is you're trying to come up with assumptions that you're making so they can be documented. You're trying to identify dependencies so they can be documented. Again, this goes from very high level to very detailed levels. It's very rare that you'll need to go to more than a 3-level DFD, although it's possible depending on the situation. So the example that he gives in here is one that we've looked at before, and it talks about guarding a castle. This is a contextual level DFD, so it's high level. So if you were going to bring people in to have them start the threat model, you might start with a diagram like this. Why? Just to get everybody on the same page and to have a high-level overview over what it is you plan on doing. So you can see here we've got an external user, all right, that's using the castle service. You've got the castle service that will be broken down because it's a high-level process that gives feedback, and of course because you've got here an external entity in a process, there's a trust boundary there. All right. Then you've got a remote castle external. Okay. And again, there's an input and output, but again, between every process and every external user, you'll notice there's a trust boundary. Here's the same process that they're talking about, but it's broken down into much more detail. We've added data stores, we've added more processes, we've added many more data flows between these. And you notice we still have a trust boundary here. And this may not even be complete. There's another trust boundary here. There could be several trust boundaries in here. So why do we do this? Well, we want to do this in conjunction with Stride to identify the different threats that we might have. Now eventually we're going to go through an exercise where we're going to use the Microsoft Threat Modeling Tool 2016, which is a relatively new tool. It's only about a month old, that Microsoft has built on, and it'll create, after we set up a scenario with our DFDs, then meaning the tool, will come in and look at all the threats that we have, identify them, and then put them within the Stride framework. You'll notice when you look in here, processes interact with everything, so they potentially have all effects of Stride. External entities, spoofing, repudiation, data stores and data flows, tampering, information disclosure, denial of service. Data flows can also potentially have repudiation issues. So you want to apply Stride throughout the process. And you don't worry if you've got exactly which one it is. What you're trying to do is you're trying to go through each process and each thing on the diagram, and you want to figure out which which are the points in the diagram which have the most to lose. In other words, which ones have the biggest attack surface. So now they've gone through the same one we had before, and we're identifying all those steps. You'll see that everything that actually has stride is a process. As it says here, make sure that your errors don't give away too much, so come up with generic error pages, validate everything. Assume that all input is bad, regardless of whether it's internal or external. Then once you've done this, so you've diagrammed, you've identified your threats, now you want to come through and talk about a mitigation process. Again, ideally when you mitigate, you address and alleviate the problem. But some problems are either going to be too expensive to fix, or so the chances of them happening are so remote that you just decide not to fix them. Regardless, you should share your process, you should share your mitigation strategy with the customer and let them know exactly where you stand and exactly where the product stands. You're trying to protect the customer. And as mentioned, even if you've created a great model and you've identified a lot of threats, you still want to go and find these bugs, track them, and figure out what you're going to do with them. There's 4 ways of doing this. You can redesign, which is going to take time, which is going to take people, which is going to take money, but ideally that will eliminate the threats. You can apply standard mitigation policies, software, whatever, to remove the threat. Again, it's going to take time, but you can use tried and true practices. Problem is, at least occasionally, you've got some kind of a threat that can't be mitigated using standard mitigations. So you have to invent your own new mitigations. This can be riskier, it can take some time, it hasn't been as tested, etc. Or finally, you can accept the vulnerability in the design as long as you let the customer know. In fact, regardless of which of these ways that you choose, as it says on the bottom, you should address each threat and you should let the customer know what you've done and how you've done it. So here's ways that you can use stride. You'll notice when you look through here that access control lists, ACLs, are used for tampering, help prevent tampering, information disclosure, denial of service, and elevation of privilege. And some of the other ones appear in several of the categories. Inventing mitigations is hard. Okay? It says everyone makes mistakes, whether you're an amateur or whether you're a pro. You may think that your mitigation, whatever you come up with, will work, and it may or may not. An expert can look at it and say it will work, and then it might fail out in the field. And an expert can look at it and say that it will not work, in which case you should go back and take a look at it in more depth and breadth of coverage. Alright, so finally you want to come in and validate the last step of the process here. As it says, you want to validate your entire threat model, everything. You want to go back and look at your data flow diagram again and say, does it match? Have we changed anything since we created this? Have the threats been enumerated? Have we run the stride method against our threat models? Have our system testers reviewed the models? Have we mitigated each threat using one of the ways we talked about before? Has this been checked before the final security review? If you can do that, the chances of you having mistakes when you get done are much less. So as it says, threats, for each threat you want to describe the possible attack, the context in which it will be given, the impact of the threat. For the mitigations, you want to describe how you're going to mitigate. You want to file security bugs, so you've got some kind of a written proof of what's happened, etc. And as it says there, fuzzing is a way of testing mitigation strategies. It's not a mitigation in itself. Remember, you want to be also documenting the dependencies and the assumptions that you're making. What security functions are in code? Are you sure you've hit everything? As it says with assumptions, things you note as you build the threat model. Don't be afraid to document. It's much better to over-document and have things maybe you don't need than it is to under-document and then wonder later, why didn't we do this? So, an effective threat modeling meeting, as it says, starts with a contextual or high-level DFD walkthrough. Then you may go down another level or another 2 or another 3 levels. You start to go through the different elements that are in the DFD. You identify the assets, the entry points, and the trust boundaries. You utilize the STRIDE methodology. You figure out where your trust boundaries are. And you might even go back and say, well, are we missing something in our design? Or is there something that we should do? This was a thing that they gave out, and what you were supposed to do was number, so you could tell the data flow in here. Okay, and then run this against it. All right. So finally, as mentioned here, you should always threat model whatever you're doing. You should threat model early and often. Early meaning that you should do it as early in the design process as you can. The sooner you threat model, the sooner you catch errors. The sooner you catch errors, the easier it is and the less costly it is to fix them. You should track any changes you make to the product as you're going through. There should be some kind of an electronic methodology, an electronic process tool that will do this. You should identify your dependencies and your security assumptions. Finally, there is the Microsoft SDL blog if you're interested in that. There's other resources as well. And that's it.